Hey guys, welcome back. I know you're so excited to have another video going. And we're going to start with chapter 9.1. Some of you guys, we got to get started on this information. Others of you, we have not. So here's the first thing we're going to talk about is a transformation. And it's a function or mapping that results in the change of the position, shape, or size of the figure. So we're learning about transformations, and this is exactly what they are. All right. Today we worked on translations where we slid things around. Now in a little bit we're going to talk about reflections. But first, let's talk about the pre-image. Pre-image. That means the original figure. Before you've done any transformation to it, you have the pre-image, the original figure. Once you've performed a transformation, then you have the image. It's the resulting figure. From there, we're going to talk about rigid motions, which I talked to some of you about. And it's an actual transformation that preserves the distance and angle measures of a figure. So today, when we did translation, we actually did a rigid motion. In a minute, we're going to do reflections, and that's also a rigid motion. Okay, so go ahead and on your paper, write rules. And under rules, we're going to have a bunch of different rules. The first ones we're going to start talking about are the reflections. So we'll come back to that in a second, but we're actually going to get going with reflections first. And then we'll come back to the rules of reflections, which will hopefully make it easier for you. Okay, so in the foldables that I gave you today, I'm going to zoom out here. We are going to address what exactly a reflection is. And a reflection is a flip over a line called the line of reflection. So, right here, we have triangle ABC. I did the original in blue, and hopefully you can see that. Let me see if I can't zoom in just a little bit without cutting off the paper. And I went ahead and graphed that. A at -3, 5, B at -1, 1, -1, -1, and C at -5, +2. And I went ahead and labeled those. Okay, remember I told you it's really important to label those. And it says reflect over the y-axis. So I need to identify where my y-axis is. And remember, it's the one that goes up and down. And I'm going to reflect. So basically what happens, if you'll notice, and you're looking at these, I have the same points, 3 and 5. But now, instead my x value becomes a positive. And my y value stays exactly the same. So instead of having a -3, +5, I'm left with a +3 and +5. I've reflected over the y-axis. All right, and then B, I have my -1, -1, and again, my x value becomes positive. So I have a positive x, and then my y value stays the same. Because I'm reflecting over my y-axis, my y value stays the same. All right, and now I have a -5 and a +2. Well, my x value becomes positive, and my y value stays the same. If we look over here at this problem, it's asking to reflect over the x-axis, which is right here. So the rule for that is going to be that my x value stays the same, but my y becomes opposite. So here with D, it was -4 and a -5. And this time, my x value, my x value will stay the same and my y value will become positive. So I went ahead and graphed this, and now I need to plot the points here. So I'm going to do -4, which is D, right down here, and then -3, and up 2, right here. Wait, did I do that right? -3 and a +2. 1, 2, 3, +2. So that one will be right here as well. And I feel like I made an error right there some way. and then a 0, and up 1, there's F, and then, oh, that's what I did wrong. Oh, wow, brain fart. The blue is my original, and I didn't plot that one, but I reflected my pink over the yellow. That's why I was getting all the same points. Wow. Special Mrs. Black. Anyhow, that's number 2, and reflecting over the x-axis. Sometimes you might get something where it says, here's your trapezoid, here's all the points. Go ahead and reflect it over the x equals 1. So what you're going to need to do is you're going to have to graph that line. I'm going to go over on my x value, and I'm going to plot the line going up and down 1, right? X is 1, so I plot point 1, and I graph that line. Okay, and now there isn't as much of a rule, but what I'm going to do is I'm going to keep my points the same distance away from that line. So this is my original image, and it is 1, 2, 3 places away from that image. So I'm going to go ahead and count 3 places away from that line, and I'll identify my new point. So it becomes 4, -1. All right, 1, 2, 3, 4, and then down 1. And then I'm going to look at P, and I'm going to count how many places it was away from this line right here that I'm reflecting over. It is 1, 2, 3, 4, 5, 6, 7 places away. So now for P sub 1, from that point, I'm going to count over 7 places. 1, 2, 3, 4, 5, 6, 7. And I'll notice that P sub 1 is now 8, 2. So if you'd like to go ahead and do the rest of those for this problem, that would be great. And then we're going to talk about this right here, number 4. This triangle. Here's my original image in blue, and it says reflect over the y equals x. Well, y equals x will probably end up being your favorite one, because what you do is you take the original points that they give you and you flip them. So where I had -3, 7, now I'm going to have 7, -3. And for k, where I had -2, 3, I'm going to have 3, -2. That's reflecting over the y equals x. So this should all be filled out and completed tomorrow. And you should have these rules written down. So rules, the reflection over the x-axis. You have your y, your x, y, and then it becomes x, which stays the same, and your y becomes opposite. And then you have the reflection over your y-axis. So you have your y, x. Your x becomes opposite, and your y stays the same. Y equals x reflection, they just flip-flop. And that's it for tonight, guys. I will see you tomorrow. Happy first video. Don't forget to get your syllabi signed.